Everybody got a little bite of the pork belly. That was pretty good. All right, so RHEL image mode. Show of hands, who has played with RHEL image mode? Anybody actually install it? All right, red hatters don't count. Okay, good. So this is going to be a good introduction to image mode. And then, hopefully you guys can understand a little bit what it is, why potentially maybe you would want to use it, how to get your first image mode up and running, and then, start to peel back the onion. Yeah, all right, delay. Okay, so what is image mode? Well, image mode is a new installation method to manage the operating system, but you're using the tried and true container pipeline tooling. So who here has built a container? Raise your hand. All right, so about half the room. All right, so you understand a container, images, a Docker file. We call those now container files, which is kind of a little recipe to build your container. So this is the same concept, but you're now including the operating system, creating this image, you can throw it on a bare metal or a virtual, and it's going to then have the intelligence to be able to boot that container during the boot process and run your OS like a container. This is now available in RHEL 9.6 as well as RHEL 10. All of the screenshots and kind of the little samples that we're going to go through are all based off of RHEL 9.6, but all this will still work with RHEL 10 as well. So because now we have image mode, we have to also redefine package mode, which was kind of like the default way of installing everything, but now we are going to officially call it package mode. So what is package mode? It's when you install your operating system with RPM packages. The key thing, right, is the file system is mutable. What does that mean? Is that it's changeable, right? Read, write, the entire file system based off of your, of course, permissions. You have access to change content. So image mode introduces a operating system that is based off of a container image, and the majority of the file system is immutable, not changeable, after it has been deployed. Now there are some exceptions, of course, because we need home directories, we need persistent configurations in etc, we need log files in var. So etc and var are read-write, right? So there's some options to do this. And again, based on configuration, if you've got some special data directory, /opt/mycoolapp/myawesomedata, you can configure that as well. But by default, var and etc are your read-writable locations. All right, so what we've basically done is we've taken kind of the best of both worlds, and we've collapsed that into what's called image mode. So on our left, we have package mode, which is your traditional RPM deployments, your errata. And then on the far right, we have what's called the application container, which you're probably familiar with. If you are building application containers, maybe you have used what's called the Red Hat UBI, or the Universal Base Image. Again, when you build a container, it's always nice to have a base image to start and make that your foundation, and then you lay your application on top of. So there's a number of flavors of UBI images based on what you're trying to do, from very, very small to micro, which doesn't have any concept of a package manager, all the way to a full-blown system init UBI, which can do system services and acts more like a traditional Linux operating system for more complex applications. So that's UBI. So if you kind of merge the two concepts, we come up with image mode. All right, so package mode and image mode. Again, we've kind of hit on some of the differences. DNF is your package manager. Within image mode, there's a tool called bootc. That's the user space tool that you're going to leverage to manage the image once it's deployed. Again, from a distribution perspective, package modes, RPMs, image modes is you're going to actually deploy the image from some sort of registry. You make your changes in package mode at runtime. For image mode, it's build time. So all of your ability to make changes for the core image is going to happen during your build time. And then you can manage and deploy with all of the tried and true Red Hat tooling. Everything's kind of both package aware and image aware. As we've introduced image mode, Satellite now has some understanding of image mode as well. And then again, wherever Red Hat can run or RHEL can run, you can deploy image mode as long as it's version 9.6 and or version 10. All right, let's build this out. Okay, so what do you need? You need to build or create this image. So how are you going to do that? There's a couple of ways to do that, and I'll actually show you two different ways to do that. Probably the way that most enterprises are going to build their image is they want some sort of recipe. So you're going to start with a container file, which again, if you're not familiar with what a container file is, it's the same thing as a Docker file, but we are OCI compliant, so we changed the name to container file. So a container file is the little container recipe that's going to outline the information of what maybe the source base image is, what extra packages we want to add, do we want to throw some users in there, what other commands we want to run in there. So that's what a container file is. We're going to then use some container build tooling to build that container image off of the recipe that the container file tells us about. And then we need to store that image somewhere. And again, we're dealing with containers, so it has to go into a container registry. Once it's in that container registry, we can then deploy that onto a system that is going to run Red Hat. Well, that needs to be in some form of a disk image. So we have the tooling to convert that container image into a applicable disk image. And we have, I think, 6 different disk formats that we support, and we'll go into those. You can also directly pull straight out of that container image if you love kickstarts. Kickstarts also now understand and have a stanza where you can pull from a registry and lay down that image right out of the registry via Kickstart if you want to build your systems via Kickstart. And I'll show you a little example of that as well. So what are the image mode prerequisites? Well, I've talked a little bit about boot C. Again, you're going to kind of need this base image, this boot C base image. We publish different flavors. So there's a 9.6, a 9.5 actually even, or an older 9.6 version. Version 10. You can build your own from scratch. There is a way to do it. The easy way, of course, is just to leverage and pick one of the base images and build from that and have that as your kind of that foundation. You will need some sort of a container. Again, you guys are all enterprises, so hopefully you're using an enterprise container registry that have some of the bells and whistles that you would need to run and make sure your registry is highly available and has backups and storage. Quay is Red Hat's enterprise registry, so we do offer that. It's not required, but in my example, I'm using that as the backend, so I'm just specifically calling out Quay. We also have a hosted Quay if you want to use that as a service and you don't want to deploy that on-prem. And then you can use, don't have to, you can use Satellite 617. It does include some kind of bare metal or bare minimum functionality for registry. And we're just kind of starting to get into the ability to manage a image mode system within Satellite. And that starts in Satellite 617. And then, of course, to get any of the images, you have to have access to the Red Hat registry, registry.redhat.io. So if you have a Red Hat portal username and password, you should have access to that and where you can go download those packages, or sorry, the images. The 2 images that we are going to use are the boot C package and then the boot C image builder container image, because that's the special image that has the tooling that we need to generate our. Did you have a question? No? Okay. That's the tooling that we're going to use to generate our disk format for the image that we want to lay down. So again, what is boot C? It's the user space tooling that will perform the updates. It supports rollbacks. There's actually some systemd integration, so there's some timers and service integration that we can talk about. And then it is also a first-class citizen with Podman. So we've replaced Docker with Podman because Podman is OCI compliant. So Podman is a great drop-in replacement for Docker. If you haven't made that switch yet, I'd encourage you. Very easy. All the syntax and commands should work the same. And again, Podman can support Docker files as well as container files for building. All right, a little bit more about what's actually inside the RHEL boot C container image. Like I said, there's the systemd, kernel, the boot C. There's what's called RPM OS tree. That's the OS technology that builds the file system. There's the Linux firmware, network manager, Podman, Python. There is no, by default, in our container images that we publish for boot C, there's no virt agents or cloud init. So if you need those, you would want to, throw those in during the build process if you were going to leverage the features out of cloud init or some of the virt agents if you're running on, VMware or one of the cloud providers. So the file system layout. So during the build time, that is the time that we can do all of our changes. We can edit files. We can, and again, it's just a container. So however you have, however you want to build your container, get into your container, whether that's through automation, whether that's manually, tickling the different files, or you are just going to use a base image and make some very minor modifications. But build time is the time to do all of this changing. During runtime, again, all the content except for etc and var is read-only. So if you notice, here's an example of the root, all the mount points, and you can see root is actually mounted as var root home, and home is mounted in var home. Because again, home and root need read-write access. So var is read-write, so we're mounting them through that avenue. So that's how we're doing it through for our default. And then, like I said, etc and var read-write. Etc is for persistence, and then var has some intelligence around a three-way merge, and this is technology we've been using that we got through RHEL Core OS. And then this is kind of tried and true. We've been using RPM OS tree for the OpenShift operating system that runs our worker nodes as well as our infrastructure nodes. We'll be switching over image mode in the near future. And so RPM OS tree is kind of a precursor to image mode. Sorry, did you get your picture? Okay. And this deck will be shared. All right, so image mode from RHEL. Again, here's an example if you're not familiar with what a container file looks like. Typically, you have a from at the top, which is going to say this is my source container that I'm going to start with, or it's my foundational container image. And again, typically with containers, you want to think about layers, and there's all these ways to optimize when you make changes so that the deltas are less. So most people start with a base image that is the bare minimum, very small, and then you add on what you need to make your image do what it needs to do. So in this example, right, we're starting with the default RHEL 10 base image, and then we want to maybe do a run, DNF install some special package. Maybe we want to add a couple of scripts or copy some files or run a special configuration file. And so during, you build this recipe, and then you run you have the container leverage that recipe to build your container image, and it's going to pull that down. And I'll show you how we're going to do all this. I mentioned Kickstart. So again, I know a lot of people like to use Kickstart still. So if you want to switch away from package mode and build a system using a pre-built container image, we now have a new stanza called OS tree container, and you just pass it the URL of your registry with the container image and the tag that you want to pull down during the image or during the Anaconda install. If you have the ampersand packages stanza in your kickstart, it's just going to ignore those if it sees OS tree, because OS tree will take precedent over that. All right, so let's get going. So the first thing we want to do, we need to get our tools. So the first thing is we want to make sure we have our bootc image builder. So we're going to go do a Podman poll from the Red Hat registry. It's just called bootc image builder. And we're pulling it down for 9 and 10. Again, whichever system you want to make your build system. If you're building on RHEL 9, you're going to want the RHEL 9 one. If you're building on RHEL 10, you're going to want the RHEL 10 one. And then we're going to start with actually building a RHEL 9.5 bootc and then working through and doing an upgrade to RHEL 9.6. So you'll use the Podman poll 9.6 bootc container, sorry, 9.5, 9.6, and then I just have an example of 10 as well. So we're going to pull those down so we have them locally on our system. And then we need to push those into our Quay registry so that, because we're using Quay as our central source of truth in our image repository. So we've pulled them down locally, and now we want to log in to our Quay registry. And since I don't have SSL set up correctly in my lab, I do TLS verify equals false everywhere. So I log into my Quay server, and then I tag my 9.5 server as bootc 9-prod, and I push it up to my Quay server. And I also do the same thing for the RHEL 10 boot image as well. And if you look, and sure enough, in Quay, we see that we've got a couple of containers uploaded and tagged as 9-prod and 10-latest and 9.5 and 9.6. So we're going to have different tags. Okay, so now we have the bootc build container local, and we also have our base images downloaded and then pushed up into our enterprise registry Quay. So now what we need to do is start the build process and do an actual conversion, and so that we can create that image in the format we want it to be deployed onto. So in my lab, I use KVM. KVM uses QCOW2 as the file format. And so again, here's the example of the supported formats: AMI, QCOW2, VMDKs, VHDs, Google, Anaconda ISO, and as well as RAW. So you have a number of options to generate depending on where you want this image mode to be deployed to. One thing that is nice is, again, lots of different ways to slice, slice the onion here, is how do we inject users? You can use Cloud-init. If you're familiar with Cloud-init, it's tried and true with Amazon and a lot of the cloud providers. So if you wanted to continue to use Cloud-init, use Cloud-init. There's also a way within the container build file, you can create what's called a config.toml file. And in that file, you can, in this example, right, I'm doing a customization.user. I'm adding the mskinner user. I'm putting my password, and there's ways to, hide the password, but we're just keeping things easy here. And then I'm adding them to the wheel group so I can super user up and have full access to the system as mskinner. So I have my little configuration toml file that I'm kind of going to inject during the build process, which will then create that user locally in the image during the image build process. You can do other things, like maybe you wanted to lay down some special LVM paths or storage. You can do that through this toml file as well. So there's a number of options that you can pass in if you wanted to use it via the config toml file. Okay, so now we've got our config file, and now we just need to run with Podman. Again, we're using container tools to build a container image, and we're going to leverage a container base image, and then we're going to pass in this little config file that's going to say, hey, oh, by the way, let's add the user mskinner, and I want to output it locally, and I want to use the QCOW file format, and it's going to then spit out this image file for me. So it'll take, I think on my system, it took about 10, 12 minutes because it's doing a bunch of work in the background. So once it spits out this image, now I have a QCOW file in a very specific directory. So you go grab that, you throw it on your hypervisor, you import it into whatever you need to run. And for KVM, right, you just point it to it, throw it the CPU and memory that it needs, and it will fire up and it's running. Okay, now I ran into a couple of issues now. Since I just took the default RHEL 9 image and I log in, now I've logged in with my user Skinner, but if I try to do a boot C check update, it has no idea of the Quay server or authentication for that Quay server, because I didn't take the time to inject any of that information into my build process. I just took the Red Hat default, and Red Hat default doesn't know about my internal registry. Well, there's two files that you can edit. So if you edit these files, again, this is the wrong way to do it, but this is a learning step, right? So we do the wrong way first. We edit these files manually on the image mode system. And then sure enough, if I do a boot C check image, it knows, oh yeah, I have a local Quay server. I'm supposed to go look, and sure enough, there's a new image. I can now do an update. So these, I'm just calling this out because if more than likely you're going to be using an internal registry that you will want to have and make sure that you've got this information in your build process. And I'll show you how to add that through in a container file as well. Okay, one thing that caught me, and I think there's some internal debate even within Red Hat, it's probably split 50-50, should auto updates be enabled by default in image mode? Well, right now, the team that said yes won because that's the default. So buyer beware when you build an image mode image using the Red Hat default images, there's a systemd timer that's running by default in the background, and sometime overnight, if it has access to the registry and sees a newer version of the image, it'll pull it down and reboot your system. Okay, so that happened to me, and I was like, well, what? Why? I didn't do that. So I tracked it down. Sure enough, our recommended method is you mask that timer out if you don't want it, because by default it is turned on. So this is how you mask it out, and now the updates are, manually, or at least under your purview. They're going to be triggered by you on your schedule, not just automatically. And then a side note, because I was like, oh, auto updates. I wonder if there's an auto update for package mode. So I did some Googling, and I didn't know this. I just learned this. Did anyone know that there was a way to turn on automatic updates in package mode? Now, you have to install a package, right? There's a DNF-automatic that it's not automatically installed, so you got to install it. But then there's a configuration file where you can put a username or an email address, and depending on what timer or